Okay, we just got through talking about descriptive statistics of one variable, and now we're going to talk about using descriptive statistics to describe relationships between two variables. I can find cursor. Okay. So looking at the relationship between two variables, that's usually called bivariate. When we talk about bivariate, we're talking about two variables. When we talk about multivariate, we're talking about more than two variables. So when you hear phrases like bivariate regression, that's just two variables. Multivariate regression, looking at more than two variables. We're not quite that far yet. So we're talking about descriptive statistics. So describing the relationship between two variables, we use all those other statistics we learned to describe one variable, but now we're going to be looking at how they're related to each other. So the way to do that is with cross tabulations. Cross tabulations are used for categorical data. So again, you have to understand how your variables are measured. Cross tabulations are used for categorical data. And the correlation coefficient is used to describe relationships between interval and ratio level data. Let's talk about cross tabulations first. Cross tabulations show the association between two nominal or ordinal level variables by comparing percentage distributions. So remember, distribution was one of the descriptive statistics we used, or we learned about talking about just one variable. And so what cross tabulations do is look at the percentage distributions for the two variables and compare those two variables. Sometimes I call cross tabulations crosstabs for short. The convention for a cross tabulation is to put the independent variable in the columns and the dependent variable in the rows. That seems to be convention. So let's look at some examples. Here's an example of looking at two categorical variables. We have ideology as our independent variable, and it has just three categories: liberal, moderate, conservative. The dependent variable, attitude toward abortion. Never okay, sometimes okay, always okay. And so this cross-tabulation is looking at the relationship between ideology and attitude toward abortion. Independent variable in the columns, dependent variable in the rows. And typically the reason that you put the independent variable in the columns and then have the percentage distributions add up to 100% in the columns is because you're wanting to look at differences between categories of the independent variable. That's usually what we're wanting to look at between the two variables. Another example could be, let's say if you had gender in the columns and something like vote choice as a dependent variable. In this case, putting the variables in this format allows you to answer the research question: do people differ on their attitudes toward abortion depending on their ideology group? That's the research question that's being answered by looking at it this way. Rule of thumb, you see down here in this corner, rule of thumb about perhaps being able to figure out if this is a strong relationship by just looking at the percents is to remember these numbers. If across the categories of the independent variable, if this difference is 30% or more, rule of thumb is that is a strong relationship. If it's less than 10%, weak relationship. So you can see that between the liberals and the moderates, there probably is not a substantive difference. Whereas conservatives would be more likely to say abortion is never okay. And you can tell that the relationship is kind of strong because there's greater than a 30% difference between the liberal and the conservative, and between the moderate and the conservative. So one way to interpret this cross-tabulation is to say conservatives are much more likely to say abortion is never okay than liberals or moderates. Liberals and moderates are much more likely than conservatives to say abortion is always okay. So that's how you can read a cross-tabulation. Let's look at another example. Okay. We saw the frequency distribution for enrollment status when we talked about descriptive statistics for one variable. This is a cross-tabulation looking at enrollment status by gender. And we have the females and the males in the columns. We have enrollment status with these different values in the rows. Oops, that's a 3. So the first number in this cell, this is a cell, just shows the count. The percent shows the percentage of females that had less than 6 credits. The percentage of males that had less than 6 credits. And on down. You can see that there wouldn't be a very strong relation, there's not a very strong relationship between males and females on enrollment status because these percentage differences are all less than 10%. So that's how you can interpret this cross-tabulation. 16% of females had less than 6 credits, 41% of females had 6 to 11 credits, and 42% of females were full-time. Okay. What about variables that are measured interval ratio? For interval ratio level measured variables, we can use the correlation coefficient to describe the direction and the strength of the relationship. Okay, so I want to point out this is for interval ratio level variables. Both variables are measured at that level. We use the correlation coefficient. Correlation coefficient is abbreviated as an R, and it's also called Pearson's coefficient, or it could be called Pearson's correlation, or it could be called just Pearson's R. You will see it that way, all those different ways. Correlation coefficient, or just R, or Pearson's, and so it's good to remember that. The Pearson's R ranges from -1 to 1. So if you were to draw that on a number scale, it ranges to -1, from -1 to 1 on a number scale. Obviously with a 0 right here in the middle. The positive from 0 to +1 means that a relationship would be positively or directly related. So from 0 to +1. A negative Pearson's R means that the variables are inversely related. And so that would be, on the other hand, from 0 to -1, the Pearson's R. So that's what we mean by direction, positive or negative. Negative, oops, and positive. So it's the sign. The sign of the Pearson's R gives you the direction. The actual number gives you the strength. So it answers those two questions of how strong and in what direction. And so here's what the numbers would mean. A 0, a Pearson's R of 0 means no correlation, no relationship. From 0.1 to about 0.4 is weak. And that's on the positive and on the negative side. The table is missing a row down at the bottom, and I'm just going to tell you what this one says. Minus 0.4 to about minus 0.1 is a weak inverse relationship. So 0.1 to 0.4, weak positive relationship. 0.5 to 1, strong positive relationship. This should say positive. -1 to about minus 0.5 is a strong inverse correlation. And then over here, the minus 0.4 to minus 0.1 weak. And so it's kind of hard, I think, to look at this in this format. I prefer looking at it on this number line. So 0 to +1, and I mean, you could even, and this is relative. These numbers are relative. These numbers, and in a way, they're kind of arbitrary. I actually wouldn't even. I don't consider a 0.5 really very strong. That's more of just a moderate strength relationship. This ends this part of the module's presentation. Please move on to review the next part